let's look at the graph's proportional relationships. So before we even do that, let's think about some of the most important things that we know about proportional relationships, which is that they have a constant rate. This means that for whatever number of things that happen, the expected result is always going to follow a consistent multiplication pattern. What this means for the graph of a proportional relationship is that they have two features. The first is that they are always going to be a straight line, which makes sense when we're thinking about that constant rate because it's showing a consistent pattern. The second thing is that it's always going to pass through the origin, that is the point 0, 0. And we'll talk about why that makes sense in a second. So we're going to use this relationship right here at the underneath to look at why some of these things are true and what the graph tells us. So it's telling us that the balloon is rising at a constant rate, which is what we said. So that's something that we can already kind of see in the picture, is that as time increases, so does the height, and we can see that it's doing so consistently, as in it's forming a straight line. Now, let's actually look at the values that were given to us. It's telling us on our x-axis that it's measuring time in minutes, and on our y-axis it's measuring height. Now, I know that the graph looks cleaner than my table, but the table is going to help us a lot to actually understand what this relationship does. So I can see this point right here is the point 240. In other words, 2 minutes gives us 40 meters in height. Now, this table is really nice and easy to read, but say our graph wasn't so simple, say the points weren't as exact on those cross points, I could still use my table to figure out some other values, just as what we've done before. I know that the most useful value is finding when my independent variable is 1, or my unit rate. So to do that here, I can see that time is dividing by 2, so I'm going to divide my height by 2 as well to keep it equivalent, which tells me that for every 1 minute, the hot air balloon is rising 20 meters, which again, we can see right here. And that's also showing us our constant multiplication rule of 1 times 20 is 20, and we can confirm that up here. 2 times 20 is 40, and we could go ahead and confirm that using some other values in the graph as well, where it's showing us that 3 minutes is 60 meters and 4 minutes is 80 meters. So 360 and 480 both have that same multiplication rule, so we know that it's making sense to us. Now, looking at that point 0, 0 that I said we would address. If we're looking at a proportional relationship, anything that we multiply by 0, regardless of whether it's 20 or some other number, is always going to give me 0. So that's part of why it makes sense that for any proportional relationship, 0, 0 is always going to be on the graph, because it is always going to follow our multiplication rule. So I can see here from this relationship that it takes 0 minutes for the balloon to rise 0 meters, which makes sense. It started on the ground. 2 minutes for it to rise 40 meters, as well as all those other values that we talked about along the way. Now let's actually look at another one and use it to answer some questions. So here it says a grocery store sells cashews, and it's telling us that the relationship is being shown in the graph. I can tell that this graph is definitely proportional because number 1, is it a straight line? Yes, it is. And number 2, does it go through the origin or the point 0, 0? Well, I can see that right there. Yes, it does. So it definitely is proportional, which means that it's going to follow a multiplication rule. But we're looking at actually some of the details here. In other words, interpreting the points in that graph. So let's go piece by piece. This first one is asking us to look at the point 0, 0. So I'm going to mark that on my graph right here. We know that the x-coordinate of that point is telling us the mass, and the y-coordinate of that point is telling us the graph, or rather the cost. So it's telling us that x is the mass, so 0 kilograms, and y the cost, $0. That's exactly what it says right here, so we know that this statement is true. The second one, the point 260, that's this point up here that I just marked, shows that the cost is $2 for 60 kilograms of cashews. Well, I'm just going to do the same strategy and match it up. Here, it's telling me that 2 is the mass and 60 is the dollars. Is that what this statement says? No, it's not. This one says $2, not 2 kilograms. So that tells me that this statement is not true.